Hello everyone, please be welcome to this second episode of ChemiWorldClasses, right? Okay, my name is Salvador and I am going to teach you a new topic about the definition of chemistry in this video and its main branches or disciplines that are inside of chemistry. If you want to stay with me, we are going to learn a lot of new things. Let's start with the fun. Welcome to ChemiWorldClasses. Okay, let's start. So, we are going to start with the question, what is chemistry? Okay, as in general, when you have a definition, sometimes you cannot find a definition that is generally accepted, but in chemistry you are going to find some keywords in order to define it. Those are, in my opinion, change, transformation, properties, and matter, right? So in this case, chemistry is the science that studies the transformations of matter in terms of structure and composition, as well as the mechanisms and the energetic part, by which these are carried out. It's not so difficult, simply as that. That is chemistry, right? Okay, so what is the main purpose of chemistry? So in the chemical industry, you are going to transform the raw materials such as metals, oil, and even natural resources into more refined products such as the cake of your birthday, the makeup that you use daily, plastics, food additives, synthetic fabrics such as nylon, for example, and cleaning products. Also, you may have some drugs in order to treat or prevent the diseases. And actually, nowadays, even the vaccines against the COVID-19 disease. So, in this manner, talking about the chemistry branches, we are going to distinguish 5 of them. Those are organic chemistry, analytical chemistry, biochemistry, physical chemistry, and inorganic chemistry. We are going to see in a moment what are the definitions and the fields of study of them. Analytical chemistry. Study the chemical composition of a sample in terms of the identity of its components and the amount of them that you have. So in this manner we can distinguish between qualitative analytical chemistry and quantitative analytical chemistry. What do they mean? Qualitative accounts for which ones. So which ones do you have in a sample? And quantitative for how much or how many ingredients or elements do you have in a sample. In this manner, we can answer these questions by using instrumental analysis. Instrumental analysis is a subdiscipline inside analytical chemistry. What is this about? In instrumental analysis, you can study the performance, the design, and even to propose new techniques in order to determine what is the concentration and what are the identities of certain substances inside a sample. So, for example, we can study the use of a pH meter in order to determine the acidity of a sample, a centrifuge, a gas chromatograph. That is one, it's very important nowadays in order to determine a lot of samples, glassware in general, and a spectrophotometer, right? I know that it seems that those are very, very difficult words to memorize. But little by little, if you permit it, I'm going to explain you in more videos what is the functioning of this apparatus. You are going to see that it is not difficult to understand the main basis. No matter if you are not a chemist and you are only a student trying to learn more. This is the idea. Okay, analytical chemistry. It's going to serve us in many scenarios. For example, when you are determining the amount of pesticides, for example, in a soil, or the quantity of the active ingredient inside a drug, for example, that could be very useful. The quality of the water that you are drinking at home, even in biological samples such as blood, urine, etc. And even for plant tissues, so you can determine what are the properties of a given plant that you have observed that it has certain anti-inflammatory characteristics. I don't know, for example, right? So I am just guessing. And if have you ever seen these kind of programs, such as CSI? Actually, the chemists that are in the laboratory are analytical chemists because they use forensics in order to know who is the guilt in the series, right? So thanks to chemistry, you can see CSI. Let's talk about organic chemistry. Organic chemistry studies the properties, synthesis, and reaction mechanisms of compounds formed by carbon chains. In this manner, oh, it's Snoop Dogg. No, I was not talking about that change. Yes, I like Snoop Dogg, but I was talking about the catenation property. What is the catenation property? The catenation property is observed in some elements such as carbon, in which you can form very long chains. And why is this so important? Because thanks to that property, we can construct or we can use the carbon as a building block in order to create more complex molecules that actually are sustaining the basis of life. For example, having in mind that we have carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur, the organic chemistry relies on the properties of these 6 elements. Why? In order to construct the so-called biomolecules. But we are going to discuss that later. For example, in organic chemistry, so you can synthesize some important molecules or design another. For example, have you ever seen or have you ever heard something about acetyl salicylic acid? Okay, I suppose yes. Have you ever had a headache? Actually, the acetyl salicylic acid is more common in this presentation, aspirin, right? So you can use aspirins in order to treat those headaches. Why? Because the acetyl salicylic acid is the principal ingredient inside the aspirin. Okay, so using organic chemistry, we can synthesize very useful molecules in order to treat health problems, but in some cases, you can synthesize another kind of things. You know what I mean. Okay, let's talk about biochemistry. Biochemistry, it studies the chemical processes in living organisms. And actually, we are going to return to the explanation of the 6 elements that I gave you previously. Carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. Why? Because they can form the so-called biomolecules. What are the biomolecules? As their name indicates, they are the molecules sustaining our life right? So they are going to be molecules directly involved in the functions of living organisms. So we are going to distinguish four kinds of biomolecules. The first one, it's called lipids or fats. This is the structure for the cholesterol. So we may have triglycerides. And actually, these kind of molecules are very important because they are forming part of the cell membrane that every one of us has, that actually every living organism possesses inside their bodies. So we can find lipids in many foods such as meat, some seeds, avocado, natural oils, etc., etc., right? But we need to be careful with the abuse and the consumption of these materials because they can lead us to serious problems of health, right? So please be careful. Okay, the second biomolecule is called the carbohydrates. The carbohydrates are called sugars commonly. So you can find them in a several ways present in foods such as potatoes, banana, bread, etc. And the main function as Goku is to provide us of energy, right? So the carbohydrates are going to be the main source of energy in our bodies. Okay, proteins. Proteins is the third class of biomolecules. Those are made of very smaller pieces that are called amino acids, right? We are going to have 20 amino acids. In this case, I am showing you only some of them. However, when you mix these amino acids together, so you can form peptides, right, by the union of several amino acids. And when you have a lot of peptides, so you can form proteins, right? The proteins, actually talk about proteins deserves an entire series of videos, but in general, proteins can um, can be present in all the living organisms, of course, and they are going to have several functions, right? Such as defense, regulation, catalysis, etc., right? But in this case, because this is only an introductory video, I would like to say that we can find proteins in foods such as meat, eggs, cheese, etc., right? And their main function in our body is to make our muscles grow, right? The last kind of biomolecule studied in biochemistry are the nucleic acids, such as the DNA. And actually, as every one of you knows, this is the molecule responsible for the carrying of the hereditary characteristics in the individuals, right? So, for example, here we have Abraham, Homer, and Bart. They are sharing part of their DNA, right? Let's continue with inorganic chemistry. It studies the rest of the elements different from long-chain carbon compounds, their properties, synthesis, and applications. Please be careful because actually CO2 or carbon dioxide and carbon tetrachloride are considered also inorganic compounds because they are not forming long chains of carbon. Actually, on ancient times, there was a more strict division between organic and inorganic chemistry because there was the belief that some kind of molecules that are produced by the processes inside the living organism cannot be created using artificial media. However, Friedrich Wöhler in 1828 proved the contrary. Why? Because he was working with a salt that it's called ammonium cyanate, and actually he discovered that the heating of this salt can result in the decomposition of this to generate urea, right? Urea actually it's a compound observed in many lithium in many living organisms, right? So actually the idea of the chemistry to be separated between organic and inorganic chemistry was not useful anymore, right? And actually nowadays this is more a traditional division more than a practical one, because if you consider the following: organometallic chemistry, that is a mixture of inorganic chemistry and organic chemistry, and actually it deals with those compounds that have a metal carbon bond. So you will see that classify or these trines are useless, because you need to consider the chemistry as an integrated science, right? Okay, up to this moment, so you may ask, so what is the importance of this kind of chemistry? Does it really matters? The answer is yes, my friend. Why? Because, for example, we may have some catalysts that can convert the ethylene molecules into polyethylene. So what is the polyethylene? The polyethylene is a very used material that probably you have ever seen inside the bottles when you drink water, right? So the organometallic chemistry serves us with a new infinity, with a wide variety of new compounds that can have many interesting characteristics, such as the sandwich compounds. Delicious! What is the sandwich compound? So, can we eat it? No. So, we have a kind of family that is called sandwich compound because of the similarities in the structure. So, the first member of these compounds was firstly synthesized in 1951, and actually it serves as an anti-knock agent in gasoline, environmentally more friendly than the traditional ones, right? The organometallic compounds has also been used for treating some diseases such as Albarzan, that it was the first organometallic molecule, actually it has arsenic, to be introduced in a medicine, right, in order to treat syphilis, and the cisplatin in order to treat cancer. However, nowadays the use of these compounds is not relevant, right? But day to day, the scientists continue working to develop the so-called medicinal chemistry, right? Finally, we have physical chemistry. It is the study of the behavior of matter at the atomic and molecular level, and its processes of speed of change, energetic and mechanistic, for which physical theories and knowledge are used, right? Inside physical chemistry, we may have many subdisciplines, such as electrochemistry, chemical kinetics, computational chemistry, surface chemistry, and thermodynamics, right? Okay, what is electrochemistry? Electrochemistry studies the charge transfer reactions at an interface. Actually, this is a very general definition, but it covers a wide variety of phenomena such as corrosion, that is the degradation of metals, analytical techniques, forming what we call electroanalytical chemistry, in order to determine by using electrochemical techniques what is the concentration in a sample of a certain element or compound, right? For example, so we may have the study of several biological processes inside the cell membrane, for example. We may have the use of batteries. And finally, for example, one of the most remarkable ones is the development of new technologies involving hydrogen, because it's a cleaner fuel in comparison with the traditional one, right? Okay. And also, electrochemistry can be used in order to design new antioxidant substances capable to protect for more time our food, right? Thermochemistry. Thermochemistry It's the branch of thermodynamics that studies the energy changes as associated with chemical reactions. In order to do that, we need to use some mathematical functions that are called state functions, such as free energy, right, enthalpy, and entropy, in order to provide us information, for example, such as the nutritional facts inside the food that we eat on daily life, but also thermochemistry can tell us whether or not a chemical reaction will occur. So this is very important. Can, can thermochemistry tell us how fast processes occur? The answer is never, never, right? So never, never in the life. So you can think that with thermodynamic information only, so you can obtain some information about the velocity or the rate in which a process will occur, right? To answer that question, we need to use the another branch of physical chemistry that is called chemical kinetics. So it is the discipline that studies the speed at which the chemical processes occur, right? But of course, if the thermochemistry tells us that a process will not occur, actually the chemical kinetics never lie in contradiction with the results observed for thermodynamics, right? So this is only for thermodynamically spontaneous processes. What is spontaneous? Because it sounds like a very difficult word. Spontaneous means that happens in a natural way, right? Okay, so we can use it also for concentrations monitoring, right? Using some mathematical expressions in order to determine what will be the evolution of a system as a function of time, right? And actually, it has many applications, such as in the bacteria growth, for example. Those people who studies biochemistry or are microbiologists are interested in these kind of things. For example, drugs absorption curves. So imagine that you are taking a drug, for example, and you are taking orally, and you want to compare what will be the absorption in comparison in intravenous, right, or intramuscular. So actually, all these kind of things are studied in a subdiscipline that is called pharmacokinetics, right? Kinetics not only studies the speed of processes, but also the mechanisms by which these transformations occur, right? So this is quite important. Finally, we have computational chemistry that solves or simulates chemical processes through the application of physical or statistical models through the use of computer technology. So we are going to use models currently developed in physics, right, in order to investigate, for example, or make correlations about the microscopic behavior observed in comparison with the macroscopic one. So we can use it for predictions. What will happen if I change this atom for another, etc., right? And in order to develop new synthetic pathways, right, that actually can be the processes more effective, or for model validation, in order to validate a theory, for example, and for intelligent drug design, right? Instead of wasting a lot of time synthesizing 100 molecules, so we can approach by using computational methods to what will be the activity observed for a certain molecule in order to prevent a disease, right? And hello again. So, okay, I really hope that this video was very useful for you in order to know what is chemistry and what are the main disciplines inside of it. And actually, we can see that chemistry, despite the fact that it has been traditionally divided in disciplines, it's an integrated science. What does that mean? That all the branches are equally important, right? So, in chemistry, Actually, in real life, we can use knowledge of analytical chemistry and inorganic chemistry and organic chemistry, organometallic, right, etc., because the real life is integrated, right? Sometimes for the study it has been separated, but that doesn't mean that chemistry it's a discipline that it has those kind of divisions in real life. Actually, chemistry is what we call a central science. What a central science? Because actually it nurtures the knowledge of some other disciplines such as physics, biology, astrophysics, etc., etc., right? But also, chemistry is nurturing from those um, academic issues, those topics, those specialities, in the opposite direction too, right? So the knowledge, remember, girls and boys that are watching this video, it's integral. So this is the very true nature of science, right? So chemists are not better than physics, than biologists, right? Actually, in order to solve the problems that we have nowadays worldwide, we need the intervention of many scientists with a lot of different backgrounds, right? Okay, so I hope that this video was very useful for you. For me, that's all. If you like the content of this video, please click the subscribe button and give me a very, very beautiful like. And this is going to be the most greatest reward that I can have as a teacher, right? Okay, also, if you need some online tutoring, so because I don't know, you need some help from doing your homework, your exams, to prepare, I don't know, a project, so you can consult me in the mail that you have here and the mail that you can see at the end of this video. For me, that's all. It's a very good pleasure to be with you again in this your channel, ChemiWorldClasses. Please be welcome and see you next week for another video. Thank you very much. Have a nice day.